All right, so what we're seeing here is something that was talked about in the lecture this week. You see two intersecting lines forming two straight angles is what I want to focus on first. So we see this line that kind of goes from the upper left corner to the bottom right, forming two straight angles, which we know measure 180 degrees, and then one from this bottom left to the top right, forming another pair of straight angles. And what we talked about in the lecture was how we can prove that vertical angles are congruent or have the same measure based on this idea. So, right, if we know that A right here plus B is 180 degrees, but we also know that A plus D is 180 degrees, well, then that means that B and D need to be equal in measure. So I want to kind of take that idea and build on it to see if we can prove some things about when we have two parallel lines, right? Parallel lines cut by a transversal. And so that's what you see here. So still that same original intersection, but now we have a parallel line as well. And so I think with students, what would be really helpful is to have them pick out that second circle, right? And find that second circle. And then within that second circle, I would have them talk about maybe some corresponding parts. And I would most likely maybe connect it to like, oh, you have a circular cake or you have a pizza, like what pieces are the same size, right? And so they might pick out this part right here, right? This angle, which would be corresponding to angle A from our original circle, right? And corresponding parts, they would need to have background knowledge on, but we could say, okay, well, we know that in congruent shapes, right? Corresponding angles are the same size, corresponding sides are the same length, right? So these corresponding angles are the same measure. And that kind of is what this picture shows here. And so then I want to build on that idea to see if we can kind of make any other generalizations about the second circle and about parallel lines in general. Right, so based on what we talked about with the first circle, those same things should be true in the second, right? We have two pairs of vertical angles and two pairs of straight angles. And so those measurements are there as well. So we do see that this circle has the same measures as our original. So the two that I want to pick out from that are angle A, which you see highlighted on our original, and then labeled as angle G is an angle on our new circle. And so what you notice is that their measures are the same. And so these angles are alternate interior angles. Alternate meaning they're on alternate or opposite sides of the transversal here. And interior meaning they're inside those parallel lines. So that idea of finding straight angles and vertical angles can help us to prove, right, that alternate interior angles are congruent. And so those alternate interior angles still have the vertical angles as well, right, that they're also congruent to, right? So G and E are vertical angles, A and C are vertical angles. So then based on that, another assumption we can make, right, is if A and C are equal in measure, and E and G are equal in measure, based on equality and what we know about it, we can say that alternate exterior angles are also going to have the same measure. So kind of taking that idea of the straight angles and the vertical angles and building on it to make some generalizations about parallel lines cut by a transversal, where we see alternate interior angles with the same measure and alternate exterior angles with the same measure as well.